The mean, median, mode can all be used to indicate the center of a set of numbers. The most appropriate measure will depend on the type of data under consideration. A fundamental concept in summary statistics is that of a central value for a dataset and the extent to which the central value characterizes the whole set of data. In this video, we'll look at the properties of the mean, median, and mode, and which one is most appropriate given a set of data. The mean, median, and mode are three numbers which help define the center of a dataset. The mean is the sum of all the data values divided by the number of data values. The median is the middle value when the data is placed in order and there's an odd number of values. It's the average of the two middle values when the data is placed in order and there's an even number of values. The mode is the most common value. The mean or average is the most popular and well-known measure of central tendency. Whilst an important property of the mean is that it includes every value in your dataset as part of the calculation, the mean is not often one of the actual values that you have observed in your dataset. The mean has one main disadvantage, that is, it's particularly susceptible to influences of outliers. These are values that are unusual compared to the rest of data. They're usually especially small or especially large relative to the other values in the dataset. Here we have a list of salaries of 10 staff who work in a factory. Looking at the data, what do you think the typical salary for a worker in this factory might be? The mean salary for these 10 staff is $30,700. Inspecting the raw data suggests that the mean value might not be the best way to accurately reflect a typical salary of a worker in this factory. Majority of the workers have salaries between $12,000 and $18,000. The mean is being skewed by the two large salaries of $90,000 and $95,000, and you can see those on the end. These might be considered outliers. In this situation, other measures of central tendency might be better to reflect the typical salary of workers in this factory. We'll have a look at those now. The median is a middle point of an ordered data set, therefore it splits the data into two halves. 50% of the data values are greater than or equal to the median value, and 50% of the data values are less than or equal to the median value. The median only takes into account the middle value for an odd number of data values or the two middle values for an even number of data values. For this reason, the median is less affected by outliers and skewed data, therefore better for things such as house prices. Here we have the same set of factory workers' salaries from the last example. We're asked again what the typical salary for staff working at this factory is. Remember, the mean salary for these 10 staff was $30,700, which is being skewed by the two higher salaries. First, we rearrange the salaries in ascending order, which is from smallest to largest. We calculate where the median value lies within the dataset. The 10 data values, so we add 1 and then divide by 2, and we get 5.5, and therefore the median is the average of the fifth and the sixth value. The fifth and the sixth value are 15,000 and 16,000, so we add them together and divide by 2 to find the median. The median in this case is $15,500. By looking at the data, this appears to be a more accurate measure of our typical salary in this factory. The mode is the most easiest measure of central tendency to find. All you have to do to identify the most common value is to look for it in the dataset. It isn't affected by outliers, but there are some issues with using the mode. It's pretty unlikely we'll find two or more values or measurements with exactly the same value when obtaining continuous numerical data. Another problem with the mode is that it will not provide us with a very good measure of central tendency when the most common value is far away from the rest of the dataset. You're more likely to use the mode in a supermarket when analysing the sale of products, or in the shoe shop when analysing the size of shoes sold. The mode would tell the supermarket or the shoe store which product or shoe size they need to restock most often. Here we have the same set of ordered data from the previous example. The mode is a lot easier to identify when the data is in order or ascending order. Here it is 15,000, which was pretty similar to the median, which was 15,500. For this data set, it's a better measure of typical salary when compared to the mean, which was 30,700. By drawing a curve through the graph of numerical data, We can get an idea of the distribution or shape of the data set. The mean and the median in different ways are both useful. In the middle of this page, we have a roughly symmetric distribution data set. The mean and the median are roughly symmetric distribution. They're close together. If the distribution is exactly symmetrical, the mean and median and mode are exactly the same. And you can see where that's highlighted in the middle set of data. We usually prefer the median over the mean and mode when our data is skewed. The data sets on the left and right are skewed. In a skewed distribution, the mean is usually farther out along the tail or the stretched out part than the median. As the data becomes skewed, the mean loses its ability to provide the best central location because the skewed data is dragging it away from the typical value. The median best retains this position and is not as strongly influenced by skewed values. So in summary, the mean, commonly used, easy to understand, and it takes all values into account. However, it's expected by extreme values or outliers. The median gives us the halfway point of the data. It only takes into account middle values. It's not affected by extreme values or outliers. Finally, the mode is the most common value. However, it only takes into account common values. The mode is not affected by outliers. And that's it for this video. Thank you.